Okay guys, we'll be continuing on seeing some more examples on the concentration terms which we discussed in the past one or two lectures. So let's get started. So first we have a question that if 4 grams of KNO3 okay is present in 500 grams of KNO3 aqueous solution, then the concentration of W of KNO3 solution is to be calculated. Then what is the percentage W by W of KNO3 solution? So this is 500 gram of aqueous solution, not KNO3 solution, aqueous solution. Okay, so W by W would be 4 upon 500 into 100. Simple as that. Okay, next question is we have to calculate percentage W by W of KOH in a solution. Okay, so you have been given that percentage W of W by V of the same solution is 40%, and the density of the solution, or rather density of the solution, yes, is 1.2 gram per milliliter. Okay, so we know that 40 grams of KOH exist in 100 ml of solution. Okay, now we can say that as density equals to mass upon volume, this implies mass of solution would be density of solution, which is 1.2 gram per ml into 100, which is 120 grams. Okay, hence percentage W by W of KOH would be 40 gram upon 120 gram into 100. Okay, you can calculate it very easily. So this is 33.3%. Let's dive into next question. Next question is you have 20 gram solute is present in 200 ml solution. The density of the solution is 0.9 gram per ml. Okay, now you have to calculate weight fraction of solute. Okay, so you have mass of solution as mass of solution would be volume into density. So volume is 200 and density is 0.9, so it would be 180 grams. Okay, and you know that weight fraction is equals to weight of solute upon weight of solution. Weight of solute is 20, weight of solution is 180, weight fraction would be 1 over 9. Okay, next question is you have to calculate mass of HCl in 50 ml HCl solution. Okay, density of the solution is 1.2 gram per ml. Okay, containing 40% concentration by weight. Okay, now from this information, first let us calculate mass of solution. Mass of solution would be nothing but density of solution, which is 5 into, or rather 50 into, sorry, density is 1.2, so volume, anyhow the factors remain the same of multiplication, it would be 60 grams. Okay, now we have to calculate mass of HCl. So mass of HCl would be 40% of weight of solution, so which is 40% of 60, which is 24 grams. Okay, next let's look at next question. We have to convert 20% W by W and AOH solution in mass percent if density of solution is 1.2 gram per ml. Okay, so we have been given that 20 gram NaOH exists in 100, sorry, this is mass by volume, W over V, 100 ml of solution. Okay, so what would be the mass of solution? Mass of solution would be density into volume, or V into density. Okay, so V is 100, density is 1.2 gram per ml, so volume would be, or sorry, mass of solution would be 120 grams. So weight percentage would be 20 over 120 into 100, which gives us 16.66 percentage. Okay, let's calculate, take a look at another question where you have been given that what volume of 90% by weight C2H5OH whose density is 0.8 gram per ml must be used to prepare 15 cc of 30% alcohol by weight. Density is 0.96 gram per ml. Okay, so we can just calculate it like this. So let's say we have 90% by weight C2H5 aqueous solution, so 90 grams of C2H5OH in 100 grams solution. Okay, density given is 0.8 gram per ml. So you have to so you have been asked what volume should we use. So let it be X gram of C2H5. So what will be the weight of solution? X by 0.9. Okay, so density is this, so volume would be mass upon density, mass upon 0.8 would be the volume that has to be used to prepare 15 cc. So new volume is 15 cc is 15 ml only, so 15 ml. Okay, and then we have 30% alcohol by weight. So let's say new, so 30% by weight, so 30% by weight would be so in both the cases what thing would actually remain constant? So the thing which will remain constant would be obviously mass of C2H5OH. Okay, so mass of C2H5OH in V nu and density nu is 0.96. So mass of solution would be 15 into 0.96. okay, this is the mass of solution, this is the density of solution, I forgot to mention. So mass of C2H5OH or alcohol would be 30% of mass of solution. So 0.3 times 15 times 0.96 is the mass of C2H5 in the new solution, and in the previous solution so I'm just erasing this for a time being. So this is rather, just a second, this is rather, we can say that what volume or what mass was present previously in the previous solution. So we would get it by 0.8 into what is the volume. So let's say we have x as the x was the volume of solution, okay, and 0.8 was the density of solution. I forgot to mention here that it is a density of solution. Okay, so mass of solution or previous solution would be 0.8 into x, okay, and mass of C2H5 would be C2H5OH would be 0.8 into x into 0.9, as it is 90% of the weight of solution. Okay, so it would be 0.9 into 8 into x. This would be the older previous solution. So with the help of this we can get x. So x would come out to be 6. So x is nothing but x is volume of solution, which was required in the question. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing molarity and molality.